conference will now be recorded.
Hi, good afternoon, everyone. My name is Swati Meherishi, and I work for Springer Nature. And I will be talking to you today about scientific publishing, how to write journal articles, what is open access, citations, what should you be looking for in journals, and publication ethics. These are some of the things that we cover today. I am sorry that I could not be there in person. I was scheduled to travel to talk to you all directly, but had to cancel due to some health issues. I hope this recording will be useful to you, and I will take written questions. You can send them via Professor Ashok Day. You can send them to him by email, and he can forward them to me, and I'll provide detailed written responses, which he can post to the conference webpage or any other repository. So let's get started. A little bit about me. I currently work as the regional program leader for the books business and applied science engineering in the Asia Pacific region. Me and my team publish across all disciplines of engineering and in related interdisciplinary areas such as design, material science, sustainability, energy, etc. I have been in the publishing industry for close to 14 years and at Springer for almost 7 years. I have, besides my regular publishing interests, I have several interests in causes or research areas, including engineering education, the status of women in engineering. I also teach technical communications to research scholars such as you, primarily within the IT system during my free time. The UN Sustainable Development Goals are a big pet cause for me at this point of time. And let's move forward with what we're going to talk about in this presentation. So section 1, we're going to talk about the general status of scientific publishing and look at peer review times, look at some buzzwords, discuss things like open access a little bit. So the first question that we need to answer before we do anything else in publishing is, why do we publish? What is our reason or rationale for publishing as researchers? There are many reasons for this, of course. We publish to exchange ideas globally. We publish to validate the results we get from our research. And let's be honest, our research is not completed until it has been published, because only when it has been published has it been validated by peers. It has been found to be research that is useful, and it is important for us to publish research in good journals for it to be received by top researchers globally. It's important also to concentrate on language clarity, because we are trying to exchange ideas with the global research community, and English is the chosen language of the research community at this point of time. I would like to talk to you a little bit about what it means to publish or perish. So publish or perish is often received as something which is valid for an individual researcher, that if you don't publish your research, then your research career perishes and you have to be publishing to be visible as an individual researcher. But one thing we don't always realize, many people do not realize, is that publishing is also important for the field of research on the whole. So when you have a body of publications as a researcher, for example, for those of you who are pursuing your PhD, your supervisors or the principal investigators of the projects you're working on, it's based on their publication history, on the history of the work that they have done, that when they apply for grants, the funding bodies grant them more funds to undertake a project. And with these funds, they can hire more researchers. And that's how the field of research grows. That's how the community continues to grow around a particular field. So without enough publications or enough background, the field of research itself starts to shrink and perish because the funding tends to dry up. Also, it's important to understand that the publishing scenario in terms of research publishing is not what it used to be, say, 20 years ago. Here you see a snapshot of publishing, journal articles submitted to a set of journals from 1990 to 2000. These are relative growth from 100% baseline. This comes from an actual research paper. That's why the data is limited up to 2008. It's important to visualize what this chart is showing you here. The bottom line, the one with almost zero slope, is the number of journals and how they have grown from 1990 to 2008. And this curve is the number of submissions to the same number of journals. So you see each journal has a community, a set of reviewers, an editorial board around it. Now they are having to look at many more papers per journal than they were looking at in, say, the early to mid-90s. And what caused this explosion was primarily the advent of the internet, to start with the email system. And then about here, we see another steep rise because of the start of the submission systems, the online submission systems. So now you see that you have to compete with a lot more papers for the attention of the editors-in-chief. So the papers that you submit must stand out to be accepted, quote, quote, journal. And that's what we are going to talk about today. So before we go ahead, let me address something about the publishing timeline. A lot of times I get these questions at workshops such as this, or through our social media platforms, or through our customer service platform. How long does it take to publish in a journal? It completely varies from journal to journal and field. Typical timelines are 8 to 12 months. Most top journals and publishers are now tightening their timelines and looking at providing better service to their authors in terms of shorter review times. But you have to remember that the maximum amount of time in this timeline is actually spent reviewing and revising your paper, which is very important. Peer review is critical to your paper. And depending on the field you're working in, for example, if you're working in a fast-moving field like biotechnology or cancer research, you might find that the papers turn around much quicker than if you were working in a more traditional field such as mechanics or machine design, where the communities are split up into smaller groups of experts, and the field is actually not as fast-moving as some of the others we are looking at. So you have to make sure that you understand that peer review is important and not fall in the trap of predatory journals who offer to, or low-quality journals that offer to publish your papers very quickly. The best way to do this is to look at the website of the journal you're submitting, and most publishers are now posting average timelines of that journal's review process. So if you think that a journal is taking too much time on average, maybe you should look for another good journal which has a shorter timeline, rather than fall into the trap of poor quality or predatory journals, which may publish your research quickly, but the value of that publication would not be as high. So once again, peer review is a positive process. Please take peer review comments in a positive manner. Use them to improve your work. And also, please don't take review comments personally. Reviewers are just trying to do what's best for the field and what's best for the journal. It has to be made very clear that very few manuscripts are accepted without any form of revision. 2 to 3 rounds of review are very common. Rejections are also an integral part of the peer review process. Even if your paper is rejected from a journal, use the rejection notes to improve your work and submit it either back to the same journal or to another journal which publishes in the area. So bottom line is, peer review is a positive process. Please take it as such. I'm going to touch quickly upon some of the publishing buzzwords. We'll start with citations and citation indices. There are many different citation indices available which look at journals and index the content published in those journals. The Web of Science is one of the most common ones. You might have heard of the Science Citation Index, SCI. You might have heard of the impact factor. It's important to remember that the impact factor is assigned only by Web of Science. Web of Science is owned by an entity called Clarivate Analytics. It's important to understand that impact factors are not assigned by any which service. The actual impact factor is assigned by the Web of Science. And if you have any doubt whether journal actually has an impact factor, please log into Web of Science. You should have access at IIT Kanpur, and all of the premier institutions in India actually have access to the library system. And check that it actually has an impact factor. Okay. The other indexing service that is very commonly known is Scopus. It's owned by Elsevier, and it's also considered a good indexing service. It's important to understand how these services index content. They actually review journals that they want to index, and they continuously review them. So even if a journal has an impact factor today, maybe next year it won't have one. These calculations are made on an annual basis. So it's important to keep checking how the journal is performing in terms of impact factor, if the impact factor is important to you. Both Web of Science and Scopus have review process. They go through a rigorous review before a journal is indexed. Google Scholar and other indices, there are many indices depending on your discipline. There might be smaller indices which are considered very high quality and are considered even more important than the Web of Science or Scopus, for example. Google Scholar, please be careful with it, because Google Scholar doesn't have a review process. It is more of an aggregating database, so it indexes everything that has been publishing for a certain period of time or has published a certain number of articles, whichever comes first. And there might be also journals which are not of the highest quality, which might appear in searches while you search through Google Scholar. So be careful. I have listed the formula of the impact factor to demystify it a little bit for you. The current impact factor we are running with is the 2018 impact factor. The 2019 impact factor should be out by the summer. And it's just a ratio. Look at this when you're thinking of journals or selecting journals for your papers. Impact factor might not always be the best criterion to measure the impact or quality of a journal, because it takes time to achieve an impact factor, and sometimes newer journals might also be very high. Okay, moving on, I'm going to talk a little bit about open access. Open access publishing is important because it lets people have free access to your content. Some of the benefits of open access are that it's with funder or institutional mandates. In fact, open access evolved as a business model out of funder mandates. Funders, especially located in Europe, wanted to have research funded by public money available to the public for free. So open access evolved as a publishing model. Open access papers, as you know, they're free to read for everyone, and this increases the accessibility of the findings. So people can find content published open access much more easily. It, of course, increases downloads because it's free to download. And in most cases, it allows you to retain the copyright to your work. But it's important to understand that not all open access journals are good. There are many open access journals that exploit this model, and those are what we call predatory journals. It's important to understand that an open access journal is not always bad, but at the same time, it may not always be good. So how do you identify a trustworthy open access journal? It should come from a reputable publisher, for example, Springer Nature, Elsevier, PLOS, or a reputable society such as IEEE, ASME, or AICHE. It should have an editorial board of international experts. Some of the names, at least, you should be familiar with. And it should be indexed by common databases such as Web of Science, Scopus, or in case of biotechnology and medicine, PubMed, or EI Compendix. All of these are common databases that review and then index content. So they usually would not index predatory content. Also look at who the authors are, who are people publishing in a journal. Are those people actual experts in the field? Are those names you're familiar with? All good publishers only ask for open access fees to be paid after acceptance. So if a journal is asking you to pay upfront, I would be suspicious about it. So make sure that only after your paper has been reviewed in an open access journal and accepted, that you pay the fee after that. And if the journal is asking for it before, then that's a red flag, and I would look more closely into that journal. One very good tool to find out if a journal is trustworthy or not is checksubmit.org. They have a checklist like the one that I just showed you. And they say that you should only submit if you can answer yes to all of the questions on this checklist. You're not sure about the quality of the journal that you are submitting to. Okay, moving on. In the next section, we're going to actually talk about how to structure paper, and we're going to touch upon publication ethics a little bit. Okay? So let's get started with section 2. First thing that I will tell you before I talk about the structure of a paper is to get the study designed right. It's very important to design your study well. In most cases, when we see papers getting rejected, we see that they do not have a research hypothesis. They do not have an aim of why they are doing a piece of research. So you must ask yourself this question: what is the aim? How is this work going to advance the field? What is the question, the remaining questions in the field that you are going to be answering with this piece of research? And or what are the gaps in the field that you're going to fill with this study? Once you know what exactly is the rationale of your study, you must identify what methods are appropriate. Out of the appropriate methods, you may not want to use all the methods in a particular study that you're designing. So which methods would you be using? And what is your rationale for using these methods over other appropriate methods? Do you have all the relevant resources? Do you have all the samples you need, all the equipment, all the data? If you don't have these ready at hand, for example, if you are working at IIT Kanpur and you don't have all the resources, can you get them from another institute or a partners? For example, if you don't have resources or a piece of equipment in campus, can you instead access it at IIT Bombay, say? Or can you probably go to one of the industrial setups and let you use their equipment? These are all questions that you should ask when you're designing your study. Okay, especially those of you who are pursuing PhDs and are still looking for a study design. These are very important questions to ask yourselves. And also identify your controls. You may not be able to fill the complete gap that exists in the field. You may only be able to partially answer the question that remains pending in the field. How far are you going to go with this study? It's very important to identify that. So coming to structuring your manuscript, in general, we look at a structure for most scientific papers. Look at a structure called the INRAD model, which basically comes from the 4 core sections: the introduction, methods, results, and discussion sections. Plus you have other essential sections like title, abstract, etc. So you have to remember, you have to tell a story through your paper. So let's get started with building our story. The best way of writing a paper is to have the method and results sections written down while you're conducting the experimental study. Put in as much detail as possible. You can, of course, modify these later. Make sure you preserve all of your raw data. I have come across cases in the past where a paper was rejected because the author was not able to provide the raw data that they extracted during the experiment. They had lost it or not saved it, and this caused, and sometimes reviewers ask for them, and if they could not provide it, this caused their papers to be checked. So make sure you have as much detail as possible. Methods and results write during research, modify them later if required. Introduction and discussion section should be written after you select the journal you're going to be submitting to, because journals might have specific guidelines for these sections. Again, you might have to write them differently for different journals if you're going to submit your paper is rejected and you're going to submit later to another journal, you might have to modify the introduction and discussion sections based on the guidelines of the journal. The title and abstract are like adverts or advertisements for your paper and should be written at the end. Now let's look at what your readers want to know. The readers have 4 key questions. Why did you do the study? How did you go about it? What did you find? And so what does this do to advance the field? And these correspond to 4 core sections of your paper. Now, sometimes some journals might ask you to write a results and discussion section combined. I recommend that you split it up into parts or into paragraphs just to make it more clear to understand. Okay. Let's look at each of these sections in detail. So the introduction is basically putting your work in context and defining why the study should be done. So you need to start with a broad scope. You can see the inverted pyramid here. To start with a broad scope, what is happening in the field? What have others done related to the question that you're going to answer in this paper? And what exactly is the problem? What is the question? Where is the gap? You have to define that. And then from that gap, you have to derive your specific aims for this particular work or for this particular paper. Make sure your aims are related to the actual problem in the field. So let's start with the story of the introduction. It must have a beginning, a middle, and an end. So we start with what question was studied. In the beginning, provide background information to your work into context. Do not write a comprehensive literature review of the field. Please cite review articles that readers can refer to. There are many good review articles, and instead of writing a full literature review and using up space from your work, your paper should be about your work. There is a word limit usually or a page limit to the paper that you're writing. So use that wisely to complete, use that wisely to concentrate on your work in this paper and not on a background or the literature review. So literature review should be short and succinct. The best way is to actually cite review articles that give a comprehensive view of the field, so that, instead of citing, say, 100 papers in your literature review, you are citing maybe 10 good review articles that give a summary of all of those 100 papers, right? You can always have a list of all of the 100 papers go in as an appendix for those who are interested in going back and looking at details. The middle of the introduction should define the rationale or reason for your study. What is the problem? Where is the gap? Please do not state the results here, and keep it short and succinct. The end of the introduction should clearly state the aims of your study. Now, once again, I've been telling you that the problem in the field or the gap in the field cannot directly be the aims of your study. The gap in the field might be too wide for you to fill in with one paper. So the aims of your study should actually clearly state what you are doing in this paper. Should state the methods you will use to carry out your aims. Don't explain the methods, maybe just name them, because you're going to do a method section with more details. And make sure the citations are balanced, current, and relevant to the work you're doing. Next section is the methods section. It's important in 2 ways. The researchers in your field need to reproduce your findings. Science is only science if it's reproducible. And they also want to build on your research further and advance the field further, so they need to know how you did what you did. And for peer reviewers, it's important for them to evaluate the design of your study and validate your results. And if you use method A, B, and C, are your results consistent with the way those methods work? So what do they need to know? What was used in the study? Samples of participants. Materials, where were they purchased? How how you conducted the study, methodology, and any specific conditions and controls. For example, if you're running an experiment about air quality, you might want to talk about temperatures, humidity, and pressures at that time. How you analyzed your data that you got from your experiments or through your simulation studies. How did you analyze it? How did you quantify it? What were the statistical methods? What software were used? All of that goes into the methods section. Use clear subheadings. Each subheading can just have a couple of lines after it, but it makes things clearer. I'll show you some samples right after this. Please describe the methods in the past tense and describe new methods in sufficient detail. If you're devising a completely new method, maybe you should explain it in full detail in an appendix or do a separate methodology paper on it. Please discuss this with your supervisor. Any established method should be referenced by name, and statistical tests used should be described along with the parameters used therein. Here is an example. You can go through it at leisure. You see, we have little subheadings here which make it too much easier to read. You don't have to put color in, that's just to show you how things are highlighted here. Coming to the results section, what did you find? Again, the results section must convey a story. Use subheadings. It's good to use subheadings similar to what you did in the material section. For example, results of methods A, results of methods B, any summarizing results, any statistical results that you have. I will again show you some samples. Please use past tense to describe results. We found that the conductivity of graphene in this experiment is XYZ. For example, but refer to figures and tables in present tense. So, figure A refers to this data, right? Something like that. Please present the facts and do not discuss your results. You will do that in the discussion section. Try not to duplicate data among figures, tables, and text. If you have a figure, I think a figure is enough. If you must show it in a tabular form, then put a table in. And please don't describe your tables and figures in text. I'll show you samples. They should be described in the captions of the figures. Moving on, I'll show you an example of what needs to be conveyed in a result section. You need to convey your initial observation, the characterization of the observation, and any applications that you experimented with. For example, here is an experiment for the creation of a new membrane for water treatment. So what did we do? We fabricated a new membrane for water treatment. We evaluated the physical and chemical properties of the membrane under different temperatures and pressures, and we found the efficacy in removing particulate contamination. Okay. Here is a sample of how the result section should be constructed. Go through it at leisure. And figures are very, very important. I would like to show you some examples of figures. So again, as I said, avoid duplication with the text, and figures and tables are very effective to communicate your results. Use them wisely. So here is an example of what I mean by not duplicating content. So you see how the caption of the table completely describes the table, and any abbreviations of the table are also listed here as a footnote to the table. This enables readers to get everything in one place about the visualization item that you're using, the display item that you're using, whether it is a figure or a table, rather than having to scroll back and forth or flip pages. Similarly, you will see a lot of samples here. Once again, please label your figures well and make sure the labels are visible. Sometimes the labels are not visible in the figures, and then it comes back to you from the reviewers. You have to redo it. So if you do it well the first time around, it will cut short the time of revisions. More samples for you here. Okay, coming to the discussion section. What does your study mean for the field? So you recall that we started with a inverted pyramid in the introduction. In the discussion section, now start to contextualize your work in the reverse direction. So we take your results, summarize what you did, interpret how this is similar or different to what's happening, limitations, if any, and then why is it important to the field. First, relate to the research problem that you described in the introduction. That's very important. Okay? The discussion is often the most difficult section because you have to contextualize your work. You have to go from a specific set of results and then present generalizations around it. Okay? Please do not repeat your results in discussion section. Well, you have to summarize them, but sometimes we see discussion or conclusion sections where the result is just repeated. There is no discussion about what it actually means. And this can be a reason for rejection or repeated revisions. Okay? Please use past tense to describe results. We found that the efficacy of the water treatment membrane was 75%, and present tense to describe their implications. This means that the water treatment membrane can be used for filtering water for non-potable use. Okay? And one more piece of advice about the discussion section: please be humble. It's important to not overstate the importance of what we have discovered. So you see a little traffic light here. So prove is a strong word. Usually you don't say that your findings prove something. Show is also rather strong because when you submit the paper, it is not yet being validated by the community. So it's for the community to say whether you have shown something through your article. Rather than that, you should use more humble terms like our findings suggest that, or our findings imply that. These are some of the things that you should keep in mind. It's small things, but they go a long way in making a good paper. Please always answer the research question. I cannot stress on this enough. What was the gap in the field, and how have you managed to fully or partially fill that gap with your work? Again, break down your discussion section into paragraphs. The paragraphs don't have to be big, 1 or 2 lines, but just breaking it down really helps readers interpret and understand it better. Please present ambiguous results and discrepancies with other studies objectively. Do not get defensive about negative results. Sometimes unexpected findings and negative results are also reported. So, and also, if you have any limitations to the work that you set out to do, you were not able to complete all aspects of what you set out to do, please describe the limitations. If you don't, the reviewers will, and they will ask you questions or ask you to modify your paper, and that's more time spent in review and revision. At the end, reiterate your conclusions, mention possible applications, implications, and speculation if appropriate. Suggest future work. If you're already doing some work further to this, mention it. If you think somebody with another area of expertise should take it up, mention that. That's all considered very helpful to field research. So, to give you a snapshot of what should go in a paper, this is what you should be looking at. Think ideas logically through your paper. You have the 4 core sections here. You start with a broad scope, contextualized to your aims. Talk about the work you've done, then take your results and contextualize them in relation to the broad area of research. Make sure that your objectives or aims are directly related to the problem in the field, that the results are actually conveying what you set out to do with the objectives, and that the implications in the field somehow help resolve the initial problem. Now, I will quickly touch upon publication ethics here. Multiple submissions are a no-no. Please submit to one journal and wait for a rejection before you submit to another. If the first journal is taking too much time in reviewing, you withdraw your submission and then submit to another journal. Okay? Plagiarism is a complex issue. I don't think I can get into all the details of it today. I hope to talk to you all about it in person at some point of time. But it's important not to plagiarize or copy ideas or content from other people's work. Also, in many cases, if you're using content from your own work, you might need to take permissions to reuse that content because of intellectual property rights issues. So you must take permissions from the copyright holders in case you want to reuse any content. Okay. Improper author contributions are also a big issue in scientific publishing. If you see in any case that authors are being left out or authors are being added when they have not really contributed to the work, please report it to the journal or to the Committee for Publication Ethics. You can search for Committee for Publication Ethics or COPE Ethics, and you will find a lot of information on guidelines for authors, guidelines of how journals treat ethical issues. I think data fabrication and falsification is a no-no. I don't think I need to really tell you that. And if you're using human subjects and animals, please follow the ethical guidelines provided by your country, by your institute, and by your funding agency. If you have actual questions, specific questions on publication ethics, please send them my way. I'll try to answer them as best as possible in a written form. There is more information available on ethics on Springer.com and Nature.com. Please go through it. There is a lot of information available also on the internet about publication ethics. And at the end, I just want to summarize what journal editors want. They're just looking for good quality science that will stand up to peer review, that is original and not repetitive, and it's interesting to the journal's readership. It is an active research area. A lot of people are working on it, and that it's written in a clear, concise manner that conveys the crux of the research to the readers across the globe. That's all I have for today. I look forward to your questions. I hope this was helpful, and I hope that at some point of time I can interact directly with you all and give a more detailed presentation to you. Thank you so much for listening to me, and I hope you have a good conference. Thank you.